functions. Now there are 6 trig functions. Today we're going to talk about 2 of them. So the first one is if f of x is equal to sine x, then f prime of x. Now we drew a picture of this last class. We had a picture of sine x, and it looked something like this. So I'll draw 2 periods of sine x. And some important pieces to mark on here are pi and 2 pi, and negative pi and negative 2 pi, as well as tops of hills, which occur at pi over 2, bottoms of valleys occur at 3 pi over 2, as well as negative pi over 2 and negative 3 pi over 2. So this is our original sine function, and if we want to graph the derivative, well, the picture of our derivative, like we did last class, we're going to identify tops of hills and bottoms of valleys as flat places. So I'll mark off some important pieces here again, negative 2 pi, negative 3 pi over 2, negative pi over 2, pi over 2, pi, 3 pi over 2, and 2 pi. So places that are flat on my sine function are at negative 3 pi over 2, negative pi over 2, positive pi over 2, and positive 3 pi over 2. Cool?
So then no matter where that sine function is located, the y are centered around on the y-axis, it's always going to come back to the x-axis and center around that?
That's exactly right. That's exactly right. So that comes from, even if I think about a function, like I'm not going to use a trig function here, but even if I have like x squared plus 3, when I calculate its derivative, well, the derivative of x squared is 2x, and the derivative of a constant by itself is 0. And if I shift the x squared in a different way, if I shift it such as x squared plus 520, so shift it way high, then my derivative, still 2x plus 0. So no matter how that graph is shifted vertically, the derivative remains exactly the same. And that's true for the sine function as well.
So the derivatives for anything plus b is going to be the same?
Yeah. Yep. Okay. Absolutely. Okay. So here we've got our zeros. Now, let's see, our sine function between negative 3 pi over 2 and negative pi over 2 is decreasing. So our derivative will be below the x-axis, with the lowest point below the x-axis occurring at negative pi. From negative pi over 2 to positive pi over 2, the steepest point occurs at x equals 0 on the original function, so that is the highest point on my derivative function. Similarly, I'm going to keep going, and I will also add my final branch over here. And so the comment that was made last class was that, wow, this function sure does look an awful lot like the cosine function. Now, one thing is that I know that the sine function is bounded between positive and negative 1 along the y-axis, and so it's not clear from our sketch that this graph is also between negative 1 and positive 1. So our sketch here is a nice rough estimate, but it's not guaranteed based off the sketch that f prime of x is equal to cosine of x. To convince us of that, we need our limit definition.